Hi guys, welcome to Kotlin Thursdays. Last week, we figured out how to write primitive filters and apply them to our own images with the OR function. We could continue to write individual functions that feeds two images, but in Kotlin, we have the ability to use a single function that accepts two images and another function with the help of higher order functions. In programming, programs may take data as parameters and pass those parameters into the function to return a different output or alter the behavior of a program. Kotlin is a functional language, and one characteristic of a functional language is that functions are also able to treat functions as data. You can pass a function as a parameter, which is really powerful. Ruby facilitates higher order functions with yield, which involves passing a block to a method. In Kotlin, the equivalent of block code is known as lambda functions, indicated by the pattern A, B goes to C, or A dot B goes to C. Instead of passing the object as an argument, you can invoke the lambda parameter as if it were an extension function. You can pass a function with double colon. The double colon is used to get the function or the callable reference in Kotlin. In this case, we're going to work with a general function as opposed to an extension function that is invoked with a qualifier. The function we will write will take a filter function and two pixel readers. Our function parameter, in particular, will only accept functions that take two color parameters and returns a color. So here, the input function that accepts the two parameters is the receiver type. And we're going to go ahead and fill out the rest of the parameters required for this function. Of course, like all the other ones, we're going to have our A pixel reader and B pixel reader, and we're going to return a writable image. We're also going to loop through our respective images by going through the rows and the columns, and of course we're going to pass in the function that we have in our parameter. When we pass in our filter parameter, we're still required to put in two parameters of the type color. So we're going to go ahead and feed in the pixel that we get from both A and B at the respective X and Y places. And last but not least, we're going to return our result writer as always. And this might have been an oversight on my part, but I actually kind of mixed up the types for the result writer, so I have to change it back to pixel writer instead of writable image. IntelliJ IDE is very helpful to help you determine what's wrong with your code. So it looks like our apply filter is complete. Let's go ahead and pass it up to the top so we can go ahead and start playing around with our apply filter. And now we're ready to go ahead and apply our apply filter to the image view. Of course, we're going to use our double colon to reference the filter we wish to pass in, which in this case is OR. We don't really care about the parameters that passes in because we're going to determine those parameters in the apply function itself. We're going to have to pass in our pixel readers, and that should be about it. We're going to remove the OR filter and we're going to double check that it works. Alright, we have a similar result, nothing's broken. And the cool thing about our apply filter is that we can pass in any function that takes two color parameters and returns an output. We can also pass an AND to get the result of all the black pixels into images that share two black pixels. You'll notice that if we try to pass in the not parameter, this is not going to work because our not parameter actually only takes one color parameter and returns a color parameter, unlike the two that we require. Well, I hope you had a lot of fun learning about TornadoFX and Kotlin. Image processing was something that I touched upon in my talk at KotlinConf this year, so I was really excited to kind of finally get into the nitty-gritty about pixel math and image processing. If I had any more challenges to add on to that, feel free to go ahead and try to implement your own RGB system. Until next time.